Okay, this should be my final video for you guys for the evening geometry. This is my Principles of Mathematical Analysis textbook. It's a college or graduate level textbook. Several of you have asked the question, and certainly came up in third period today, what is the difference between a property and a postulate, or property and a definition? And they are functionally the same, but I'm going to give you a little bit of the background of where they come from. These are the axioms for addition, and these are the axioms for multiplication, and they are all pretty straightforward. The commutative property, the associative property. There's some additive identity here. The inverse operation, the fifth axiom is for addition, is where we get subtraction. These are the things that for the real number system and its construction we take on faith. They function exactly like postulates do. We just call them axioms because of the context. For multiplication, we have sort of a definition. Well, that's about set theory. Multiplication is commutative property, associative property here, the multiplicative identity, and the inverse operation for multiplication, which is where we get division. So this right here are basically the postulates for fundamental foundation of mathematics, or the real number system and the complex number system for that matter. And then, of course, we have the distributive property over here. And from those 11 axioms, we get some real basic stuff, proposition and the implications. So our properties are growing out of those axioms. So that long list on page 600 whatever in the back of your geometry textbook comes from those axioms and some of the propositions that follow directly from those propositions. Functionally, we can just take them on faith, just like we do postulates when we're writing proofs. I also want to point out the connection to conditional statements. So take this proof that we started class with. If two angles are complementary to the same angle, then the two angles are congruent. That is a conditional statement. With a hypothesis, if two angles are complementary to the same angle, and a conclusion, then the two angles are congruent. So we want to verify that hypothesis, which is our given information, the hypothesis. And then the conclusion is the thing that we aim to prove by way of deductive reasoning, the application of axioms, properties, postulates, definitions, and previously proved theorems. Ideally, as we move forward in class, I don't give you anything given, and I don't give you anything to prove. I just give you a theorem. And by reading the theorem, you're able to identify what information you can consider given for that theorem and what you're supposed to prove. So take another example. Here, this proof we also did in class. If two angles are supplementary to the same angle, then those two angles are congruent. The given information is two angles that are supplementary to the same angle, and they have arbitrarily defined those angles. R and S are each supplementary to T, the third angle. And then they aim to prove that those two angles, R and S, are congruent. One more look, perhaps. Well, so in the beginning here, we hold your hand a lot by just giving you givens and ask you to prove. But as we go forward, we want to be able to take any theorem and convert it into given information, something that needs proof. So I can't find an example quite offhand yet. So that'll just be the end of this video. If you watched all the way to the end of this video, I am going to take neither 6 nor 7 up for a grade tomorrow, but I do want you to have both of them done so we can look at them together and make sure that you are on the right track. The next place we have to go in the textbook is activity practice 6.1, and there's lots and lots of proofs for you to do in there, 2-column proofs, conditional statements, multiple choice, correcting mistakes in proofs, and on and on and on. So there you have it.